Hello, ladies and gentlemen. Today's video will mark the second video of the series of creating an elevator system, a working elevator system. In last video, we were able to create this elevator system in Factory IO. This is only the exact part I just showed how we got each part, and I can just use your imagination and put all of the instances in one line and put them exactly like this. But you kind of got the introduction to all of these, and if you don't, then do go to that video before we to also here. Anyways, in this video we'll be just looking at the code itself, the code that will enable us to control this elevator based on inputs that will be triggered in the switch in the various switch boxes. Again, remember this switch box is supposed to be in here, but due to factory IO's nature, this elevator cannot go up with this switch box, so I have to put it out here on this column, and then each of these switch boxes are the various floors. So we have 4 floors: ground floor, floor 1, 2 and 3. And so let's check on our code. So as usual, we have just one organization block, which is the main block. The main block will be the very first block of code that will be run by the operating system, or in our case by the PLC sim. Okay, and so we have function blocks and data blocks. So function blocks and data blocks, we'll look at each of them. Basically, function blocks are just sections of codes which would have otherwise been your main block, but due to the familiarity or similarity between the various ladder networks within each of these function blocks, we rather just group them and put them aside from the main block and then call them when necessary. Otherwise, we have like redundancy, like imagine there's a particular case where door 1 is open whenever the elevator reaches floor 1, when door 1 opens, and then all the others are closed. So what do? You open the door at floor 1 and close the doors at all the other floors. But now when you reach door 2, you need to get up there, you need to open the door at door 2 and then close the other door. So that's like why not just utilizing this same door, this same set of networks, and utilize it. Okay, so me talking will really help you to explain. So let me open one of these function blocks. Let me first of all go to the main and show you how it is. Today we won't really be writing the entire ladder program, but at the end of the video I have a special surprise for you guys, so stick around to the end of the video so that you get your surprise. Okay, so this is our main program, which is having the function blocks. So let's open the function block, and this is door 2 open here. So basically, door 2, what does it do? So far as the system is on, door 2 function block is going to close each of the doors in all the other floors and only open the door at floor 2, and it's also going to turn off each of the lamps at all the other floors and going to on the light only at floor 2. Alright, so from here I can easily explain to you that suppose we did not have a function block and this was just set in the main. Okay, this was just set in the main. Each of those lines or networks will be set in one of these rungs. Okay, now if I want to call back this whole set of functions, suppose I want now to change a single variable, say we're at floor 1, okay, or floor 0, I want to just take a single variable and all the rest will be the same, or I want to use this exact function, this exact set of ladder, this exact network. So I need to copy all of this and put it again in another rung or in the same rung. So you see it gets a little bit too cumbersome. So that's why function blocks, just the aim of function blocks is just to ease the code, like to help condense the amount of ladder networks that you use otherwise. For example, this function block doors close. Function block is characterized by a percentage FB. So FB2 means function block 2, and we have FBA function block 1. So each time you create a function block and you set variables, it always assign itself data blocks. So now what are data blocks? To it better, I'll just go here and is to active that. So supposed to add new block. But data blocks are basically exactly the same as PLC tags, whereby they will be storing data, but instead as a separate, rather than storing it all in the PLC, no, they'll be storing in the PLC, but rather than storing in the main memory, let's say the RAM of the PLC, is going to store it in its own separate location. So what I wanted to do is come here. When I want to add a function block or a data block, you always go to add new block, you double tap. So you select function block in order to add those blocks that are extensions, so that will like compress the ladders that you want. And if you want to create your own separate data block, you just select this data block, make sure it's selected, you see data block, name your data block 1, you change it to whatever name you want, leave it to type global. Global simply means that it can be called from any of these function blocks, including the main block itself. And we have other ones if you want to call it specifically on the particular function block itself. I just like to call it global. Description data blocks, just save program data. Okay, so this is good. Like, rather than having everything in your PLC tag that's in the RAM, you can also have just a separate data block which will be storing the states of these guys and can be called from anywhere so far as it's a global data block. So let me go, for example, to moving down. After the doors are locked, if we go to moving down, go to double down on this function block for when the elevator is moving down. It's kind of loading, take its time. Okay, so moving down, what happens? That's how we check and make sure that the target floor, have a variable called target floor and current floor. Current floor is simply the floor in which the elevator currently is, and target floor will be the floor in which the user or the client or whoever wants to operate the elevator has set the floor he wants to go to. So when target floor is less than current floor, it means that we're moving downwards, right? Because current floor will be here, target floor will be less than, which means lower, and which means we want to move down. So what happens, we are going to set the elevator, the data block of the elevator for 0. So I basically made an array for the elevator variable elevator movement, where I put it to 0 and 1. 0 means that elevator is going down, 1 means elevator is going up. So let me go to that data variable. How do I know it's data variable? DB. DB means data variable. So I created that elevator. So if you go a little bit down here, elevator variable, double tap it. So it's going to load, open up. So this is basically how an elevator, this is basically how a data variable looks like, just like PLC tags. If you don't know what PLC tag is, let me go right down to that. Okay, so these are PLC tags. So you come into PLC tags. Let me open the default tag table. So the default tag table looks something like this. Kind of really limited since it's mostly used for sensor actuators. When now elevator variables, it's much more of something like, I would say, programming, but it just stores the program data, the data each of these. So we have floor door, we have push buttons. Push button instead of as an array for push button floor 0, floor 1, floor 2, floor 3. Or when the system is on, we have data variable to store that. Current floor, we have data variable to store that. Target floor and elevator movement. We will have 2 elevator movement. When it's moving up, let me try and extend this. Extend. No, it doesn't want to extend. Oh my. Okay. Can you see it? Wow. So I created elevator movement, which is an array of booleans. So we have elevator movement 0 and elevator movement 1. When I said elevator movement 0 will mean that the elevator is moving down, elevator movement 1 will mean that the elevator is moving up. You can change this name to whatever you want. If you set it as array, it's a little no, it's not really complicated. It's my bad. You can just change it. So now, never mind. You have to change. You just have to create 2 different variables. Change their values. I mean the data type. You just tap here, and then you select whatever data type you have. So you can create an array, you can create a boolean, a byte, a character, a decimal integer, a decimal word, a date or data time, and there's just so much to use. So for this elevator system, the main one you use may be an array of any of these, a boolean, a byte, or a decimal integer. That's from my code what we did here. Okay, so moving back to moving down. So this will set the motion downward, and this will reset, that is turn off motion upward, because we don't have a deadlock. We want to make sure that we're moving downward, we're moving just downward. And basically, since we know that our target flow is lower than our current flow, the elevator shouldn't be going up, it should be going down. So now that we've set it moving down, now we're going to put here an input checking that if elevator movement has been set to down from the data block, therefore set the actuator to be descending. What is this actuator here? With the actuator will connect to elevator down. This elevator down actuator will be connected to this guy here, 124.1. Okay, so that's and all. I just want to clarify, I want to ensure that everything will be done. Just want to close this guy too. If I can, yes, I can close it. Okay, so don't worry too much about the code. Just my aim for this video is just for you to understand function blocks and data blocks. So data blocks are basically like the PLC tags which I just showed you, but now you can have data blocks for each of these function blocks. When you create a function block and you put data in it, a data block will be automatically stored for them, just as you can see here. So I have a moving up and a moving down data block because I have a moving up and a moving down function block. Even this door closed, data block is here, function block is here. So each data block is associated to a function block, just like this main program is associated to this PLC tab. And you can also create your own separate data blocks, just like this one that I create here, the elevator variable, and you ensure that it is set to global so that whichever other function can call it. Now why is it really important? Because suppose now, let me go back to the elevator variable. Suppose from one function, let's say a function to request, let's say a function to stop the elevator, a function to be moving down. So when moving down is set, this guy will be set to true, this guy will be set to false. But now if something like an emergency or the stop button was pressed, this stop elevator is going to call again this variable and set it to false, thereby making the elevator moving neither up or down, which means the elevator has been stopped, everything stopped. Same thing for the indicator lights. It's going to come to the indicator lights, put them all to maybe off or put them all to red, close all the push buttons, so like it eases the accessibility of data rather than putting it all in one spot. Like I have different places to activate or deactivate data. And same thing for the function block. I suppose I want to abruptly stop them moving down, but I don't want to stop the entire program. Rather than going to my main and start fumbling or like searching endlessly in a really long and tight fitting code, which would be really not appealing to watch. Like all of this could be, you could like compress some of this into a function block. But also it's important to note that there's no clear number of function blocks you can create. You can create one, you can create 1,000. It just depends on how much clarity you want in your code, because you can really compress each of these lines of code or each of these separate sets of code into a function block and just drop it here, drop it there, drop it here, drop it there. So it's all about your own, like the way you understand your code, the way you want your code to run. And basically function blocks, let me say the number one priority that you want in your function block is to ensure that your function block should answer the particular question that will it run, and also if I compile it, will it run successfully. So function block are there also to ease compilation. That is, you can compile this separate line or networks. If this runs, it means that when you put in 9 in main, it will definitely work, and you can just bind it with other things and work with the flow. And that's another thing. Rather than having a completely long set of different networks, and now we want to compile, you get some kind of 135,000 errors. You can just compile these, and insofar as you have compiled each of your data variables, each of your function blocks should work, especially the data variables that I have created. So mine is taking a little bit of time because I have a lot of things open up. So it's going to compile, it's going to write here at the end if there are any errors or warnings. So it's the compiling configuration. Again, make sure that whenever you're compiling, if you get an error, go check by your data variables, especially those that you have created yourself, and make sure that they have been compiled. So yeah, compiling finished, 0 errors, 0 warning. That is great, that's what we want. So like I said, if you get an error, make sure you go to your data variable that you created and make sure that you come here to compile and get this compiling finished. And if it's done, you go to your function block that you the most recent function block that I've created, although it's not necessary, but just to ensure that that way I've written that is correct, you compile it. You don't need to compile each of them, just compile the data variables that I've created, each of the function blocks. Once you have compiled once it's worked, you can just go to your main and compile them. Now, how do I connect a function block in my main? Because really none of these function blocks will be run unless they are in the main. If they are not in the main organization block, this is what it's called. You see, main is basically the very first. In C programming, main is basically the first function that will be called. Let me now go to programming. So main is the first and foremost program that will be run. None of these other blocks will be run. And so to ensure that they run at particular places, you come and put them in your main. So let me go to my very first network in my main. So my very first network, when the start button is pressed and suppose the stop button is not pressed, the system will be on. The data block elevator variable which I created will set the system on, which means that the system will be on throughout. So if this is a push button, we know that after you have been pushed, when it will be released, no coil will flow here. So that's why I put it this to set, so that once this push button will be released, you will have at least set this value, and so the system will be on throughout, unless you press the stop button which is down here, and now doors will close. This door close will be set, which means all the doors will close and you go back to initial. Okay, so same thing with stop button, just the reverse both of those. So if you press the stop now, it's going to reset the system variable which is storing the system state, and it's going to like stop the motion of the elevator. So you're going to put movement elevator downward, reset, movement elevator upward, reset. Okay, so movement of elevator upward. So to know whether the elevator is moving upward, you just use a comparator. By the way, whether it is comparator, you come here to instructions, select instructions. I've deselected it instead, so I'm going to select it back by clicking on it once. It's going to show you basic instructions, and now comparator operations. Comparator operations, you can just drag and drop here and then assign your data variables. Oh, one more thing, very important. How do I set these variables? Okay, so this was target floor, so I'm going to cancel all of this. I'm going to leave it blank, trying to leave it blank. And now you can either write all those long names or you just press here. So my target variable, my target flow was in elevator variables. I'm going to select elevator variables, and this is here, target variable. And I just say there, press enter, and that is it. My data variable target flow is set here. It's going to compare to make sure that if target variable is higher than the current flow, it will mean that what the elevator has to go up. So you're going to check and make sure that there's no interlock, because if the elevator is already going downward, you have to wait until the elevator is idle. So when the elevator is not moving downward, it's going to now check, is the system on? Is the system is on? Now it's going to wait for 5 seconds. This 5 seconds is part of my code. It's not really necessary, but if your elevator has to wait for 5 seconds, like showing case, like in our case, our elevator has to wait for 5 seconds before it operates completely. Because of 5 seconds, this 5 seconds delay is just to ensure that if there's any other request to be made, it should be made, and after that 5 seconds, they will not be made. So after that 5 seconds, we're going to energize this memory bit. This memory bit will not be energized, and now leave current flow. The door, all the doors will be locked, and the elevator will be moving upwards. Same thing with downwards. If target flow is lower, elevator, ensuring that the elevator is not moving upward already. It's not moving upward, go down, interlock down, the elevator is trying to move it upward and downward at the same time. Suppose the system is still on, you need to wait for 5 seconds for any other request. We're going to set memory bits on, and therefore this will be on. Close the door, and you'll be moving downwards. Last but not least, we have sensors. This sensor here, let me just open it up. Sensor is basically the function block that we holding our sensors. You can remember we placed sensors at each of these points. These are the sensors here. So we need to make sure that when these sensors are touched, that is when the elevator passes the sensor, it's going to set now the value of the current flow to that flow of that sensor. So that was just to illustrate. So as you can see from here, so zero flow sensor, that's the ground flow sensor. So it's going to use move. How do I get it moved? You come to instructions, you get move, and then you move, you drag and drop it here. So at the input, I will just put a decimal integer 0, and then here will be current flow. That's at my elevator variables current flow. So we're going to move this value into current flow. So current flow will now be 0, because why? Because flow sensor 0 will be signaled, and so when flow sensor 0 is signaled, it's going to push 0 to current flow. It's going now to check whether the target flow is equal to current flow. If it is, we need to first of all set it to a flip-flop. Now why do we set it to a flip-flop? Because remember, these are not actuators, these are actually kind of like push buttons, because the sensor is going to like sense it for a quick moment, because the elevator is going to go like oops. Let's suppose our sensor is just going to like oops. So as it passes like this, that time is just too short for any of these other operations to occur, because we want to stop the elevator, we want to open the door at the ground floor. And so if it just passes like that, we'll not be able to pay for all of this. The current will just pass and just no recurring anymore. So I'll use a speed here to set it, to ensure that it is set, and therefore stop the elevator and open the door there. And this will stay off insofar as target flow is equal to current flow, and only when target flow will not be equal to current flow will the reset be made. This is important because an SR flip-flop, this particular SR flip-flop is arrow dependent. That is, if current flows at this arrow, even if S is set, this will be reset. But now particularly because in our particular case, we are in the scenario where target flow is equal to current flow, therefore this will be false, as no current will even pass through here to go here, and therefore this will be set. Why am I doing this? Because remember, this flow sensor is just going to sense it for a passive split second, whips. So for that split second, it's going to pass through here, and therefore it's going to set this SR flip-flop in order to stop. Because SR flip-flop is a latching device. Basically, a device that is going to store the value which has been set to for a period of time. So the latching device can be seen as a storage device. So same thing for each of the other floors. So if third floor sensor, the sensor of the third floor says it's going to set current flow to 3, then going to check the target flow is that current flow it is. First of all, you set you maintain the value, you put it to set so that this whole line will be run. If not, the sensor will just pass it, oops, current will just flow here once. I'll just state that no current will flow after the elevator has crossed the sensor. So you need to ensure that current is still flowing there. And how do you do that? You use a latching device in order to ensure current to flow, so that even though there's no current here, you will still memorize the fact that current flowed here to set, and so it's going to allow current to flow here to stop the elevator movement and open the door 3. This door 3, remember, is storing both the door functionality and also the lamps. So if you have lamps, the floor 3 is going to turn off. And so only when target flow will not be only when target flow is not equal to current flow, that is only when it leaves this 3, or when current flow is 3 and target flow is changed to 1 or 2 or 0, then it will set to reset. And since reset precedes over S, this will now be stopped, and it does the same for each and every one of them. Okay, last but not least, so we looked at the sensors, we looked at target setter. Okay, so what do we have here? I think this is just no, I don't think this one is necessary. I really don't know how this got here. Oh, okay, we're getting there. So let's first of all go to request queue. Request queue is going to store in like the remember when I said that there are 5-second delay in order to get any other information, right? Yes. So I can even just directly come to here. So whenever someone press the button, first of all, it's going to store the value inside request queue 0. There are basically 3 request queue. For this demo, I only call it demo. For this draft, I created just 1 queue. Normally you create 3 queues or 4 queues or whatever queue you want in order to store the amount of requests that will be inputted, because we want to set in such a way that we have priority in the request, because different people will be pressing. And so if you put just one variable to store the target flow, that variable will be override, and so some people will never get the elevator at their flow and to their destination, because so many people will just press the elevator at the same time, overriding the target flow. So at a particular instance, when the elevator variable is changed, it's going to be set to target variable. Now, how do you ensure that target variable gets this request queue 0? This all occurs at the request queue. So let's go to request queue. I'm seeing data variables. Data variables are all over here. What's happening? Request queue is a function block. Okay, and function blocks are always at the beginning before you go to data variables. Okay, this is request queue over here. So I'm going to double tap it. It's going to load again. tier portals. Just like factory, you need a really strong PC, a strong RAM, and video card, but that's not really a prerequisite. Alright, so we are the request queue, and I'll just look at floor 3. Now let's just go at the beginning. So here we are at the beginning. So again, it's a free flow. Why? Because it's a push button just like sensor, so it just be a split second of going up past here. So I need a latching device in order to store the state of the current that's supposed to flow here, whether it's going to be set or reset. So what flows will also suppose we're inside the elevator and we request that we want to get suppose the elevator we want to request floor 0, we want the elevator to go to floor 0, or we're out of the elevator and want the elevator to get to floor 0. It's going to set now this flip-flop and going to allow current to go here, where it's going to have to check is elevator request queue 0. So basically I told you that 4 queues is supposed to be 0, 1, 2 and 3, but I just put 1 over 2 for the purpose of the video for simplicity. So if it is equal to 5 here now, since there are 4 floors, 0, 1, 2, 3, I place 5 here to be our reset value, because normally we'll put 0 as our reset value. Since 0 means floor 0, I said took 5 as our reset value. So it's going to check if no other floor has been selected. That's why it's checking if request q 0 is equal to 5, which means that it has been this empty. It's not set. But you can actually write empty here since it's the data. It's a decimal integer, so I'm going to put 5, where 5 here means that it's empty. So if it's empty, therefore put 0 as the request queue, and now you will now go back to main and put request queue to be target floor. Same thing, same thing for each and every one, same thing for each and every other one of those floors. So now this will work, especially because we have just one queue. And now if you want to go and do 2 or 3 queue, this is more complex. I will cover it in another video in another section, but for now I believe we have covered each part of this code. Basically I told you that these data variables will just appear. Okay, suppose this very request queue that we looked at, function block, let's look for its data block. Data block 21. Let's just take this guy. So it's data block. Like I told you, so first you create a function block here, a data block will be automatically created, so you need not fear for these guys. And this redundancy, I think I created just way too much. I don't know. Let's see, because you might be wondering, but wait, Alan, why are there so many stop elevator movements? So data block that, data block 17, data block 80. Let's just open each of them. I see that are basically the same. There's not much difference in them, but do not delete them. Like, I don't even know why they appear. Surely they appear because I created different instances of stop elevator. So when you delete a function block, you need to come and delete also the data block that was left behind it. Although not necessary, but just again for simplicity and cleanliness of your work, you have to do that. Okay, so suppose we have understood data block and function block. By the way, if you have not understood something, please leave a comment below in the section. That would really help. Leave some feedback. It will really help me to understand what went wrong or what went right, and help us to move forward. But suppose all went well, we are now going to compile. Make sure you compile each of the data variables, especially the data variables that you created. So ensure that you have 0 errors, 0 warnings. So if that is said, you go up here to start simulation. You select start simulation. It's going to load. Let's move this a little bit. So if you go here and you go to drivers, you'll see Siemens S7 PLC sim, which is exactly the one that we had here. Okay, so I close this, and nobody is just back. Okay, so this is gonna show. So once I'm here, I want to make sure this is set to PNIE PLC sim. So I'm going to press start simulation sim that is set. So it's going to attempt to establish connection, attempting to connect. Basically, I have to wait until it's showing here flashlight or showing here connected or whatever it's going to show. So attempting to connect to device, scan completed, and completed. So it's completed, it's showing you orange, means that it's good. And so we're basically going to press this load. So this load is going to send all of these our ladder diagrams into our PLC system. So right now it's sending it. So we need to select all of these guys here. So you can select one by one, or you just come here to download selection, select consistent downloads, going to tick off them, and if all of these load, means that everything is good to go. So you press load, going to load configuration, downloading it to the virtual PLC, and once it's done you should see some kind of indication here, loading completed 0 warnings, and that is it, which implies that our code is now inside this PLC. Now the part that you'll be waiting for, connecting it to factory IO. So to connect to factory IO, basically I've already shown you how to configure this in the last video, but you select here, this is set to none, so you have to come here to CMS 7 PLC sim. You come to configure, you change the offset to 124, because here our offset and this value here 124, 124, 125, 126. So you change the offset to 124 for input and output. For input, I have 24 inputs from 0 to 7, like 3 times. That's like 8 3 times, so that'll be 24, I believe. And then you just need like, you need 8, I believe. Yeah, you need just 8. I put 16 just for you can put 8 here or whatever. So once you do that, you come back here. So you show like this I124.0 right up to I26.7. You need not worry yourself with these other guys or this other KZ. Then you have KL124.0 to KL125.7. And so what you do now is you drag and drop. Suppose I want this sensor 1 too slow, which I named for the sensor between the flow 1 and 2. I drag and drop here, and it's going now to assign that sensor to this input address in my PLC system. Where I don't want this, I'm going to remove this. So to remove this, I believe you just have to select it and press delete on your keyboard, or is it backspace? Wait a minute. It doesn't seem to want to come out. I believe you just drag it and dump it wherever. And so now to connect, you just connect this button here. That's all. So once it's like this, means that it's successfully connected. But to ensure that it's completely connected, I'm going to come here, make sure this is running. Okay. So this is running. I'm also going to set this to run. So if this is directly inputted, it means that because this is my sensor, this is my first sensor here. So if this is directly set here, because this is an input base, so they checked, which means that my sensor here is already connected, and this 6 here is for the system on, which means my system is on because I purposefully placed it to be on here. You can put it by selecting on the actuator and ensuring that it is forced. And when you do that, it's going to be directly through here. So once you see these ticks just appearing here, fear not, it means that your factory is successfully connected to your PLC program. And now to make sure that this works, you can control it either from here or from here. So suppose I want to go to floor 3 or floor 1, I'll press floor 1, wait for 5 seconds, then 5 seconds delay, and then it's going to go right up to 1, and when it detects that sensor, it stops there. So if I want to go now to 3, I believe 3 over here will be this button here. I just don't want to zoom in and out, so I'm going to press the button. If you press, I hear that sound. So I'm going to wait for 5 seconds. Remember, it's a push button, so you just stick and just disappear. After 5 seconds, it's supposed to move right up to here. I believe it's 3, right? I don't know when I can zoom. Let me just press it through here. So I've selected 3, and so after 3 seconds, this is floor 3, so it stops here. Great. So if I have to go back to 1, okay, I believe this is floor 1, and so it was either floor 1. So if I press, floor 1. I've heard that sound. It's a sound when you press it. I don't know whether you can get it, but after 5 seconds this is supposed to go back to floor 1. Except if my buttons are not configured. I don't know. What could be this? I think we should zoom in and find out what this button could be. Okay, so I am here. I'm going to zoom in a bit. And what could this be? Come on, I can't really see what. Okay, this is floor 3. So let's go to floor. Let's request floor 0. So I have pressed floor 0. So after 5 seconds, this elevator is supposed to be coming up. And yes, I can hear the sound. So it's coming right down. So yeah. So I want to send it to 1 because I want to use this other guys over here. So after 5 seconds, you need to move. I'm going to wait for that. And this second is to come here. It's going to stop at floor 1 here. So I'm going to request from here. So I pressed it, and after 5 seconds, it's going to come right down and stop at this sensor here. So this sensor is for speed, and the other sensor there is just to stop it at the end. And basically we're done with our program. So there you have it, complete setup of how to create a factory IO and how to connect it to PLC program. And now for your big bonus for watching to the end, I'm going to provide a link below in the description on this PLC program. Of course, this is just the draft program, but if this is what you needed for, let me say, your class simulation or whatever, if this works for you, that's okay. This is not a complete simulation for mine because you need to set priority, because if 2 people press this program, if 2 people are to press, okay, this is disconnect. If somebody is to press here and somebody is to press here, it's going to overwrite. So you need also set priority and different request queues in order to ensure that if someone presses here and someone presses here, it's going to stop both of their values and you're going to compare based on the movement of the elevator. But basically this code is just going to move the elevator up to the designated floor or down to the designated floor. So that's it for this video. Thanks so much for watching, and see you in the next one. Hopefully I complete with my own part of the code, but that's it for the video. Bye.